All right.
Like you did. Yep.
See, when I make magic, they can make magic. It's going to be that times. I'll make my multiplier up using gray numbers. So 3, if you could help me, I don't have to reach too far. I'll get the 4 and the 3. There's really no magic to use for that. I'll just put them down.
I was helping Bree.
Thanks. Okay.
Don't give me
So
a hard time.
this is going to be the problem I'm going to work from. In order to do the work, I'm going to put another mat down there because we'll want it, even though we'll work on the board too. So let's set a mat out so we have room for our products as we gather them. Maybe stretch that down that way a little bit. And let's go sideways because we don't need to get down there. There we go. Okay. All right. Now I'm going to expand notation just as we've always expanded notation. So we'll expand it going upwards so that we have the smallest place, the units place at the top. So our multiplicand. And then our multiplier, in order for me to expand the multiplier, I have to, now for sometimes what I like to do for this is I like to have it hidden under there already, so it's kind of magical. If I put this down with 43, I can expand that, and we can expand it out like this. And I pull the 40 up, because we're going to work with the unit first. So the first product I have to work with, the first multiplication fact I have to work with, is 4 times 4.
No, so you're,
I'm sorry, 4 times 3.
so you're not building top to bottom, you're building, you know what I'm saying? You're not
Right.
building 6,000 at top?
Right, I'm not in this case.
Why is that?
Because I'm going to work, because I multiply by the 4. This is exactly mirrored the way the module paper looked like. If you look back at your notes from the module paper, I've expanded exactly the same as we expanded the module paper.
Okay.
So there's a direct link to that. We're going to have probably, Nicole is probably going to have to be our cashier or our banker over there. And what should we ask her for? We're going to ask her for the product of our
12.
10 and 2.
So this is easy. She can give us 12 by giving us a 10 and a 2, and each time she could make magic if she wanted to, but that would take us like that. All right. Now when she brings it over, we're going to expand the notation horizontally, so we have a horizontal line. 4 times 3 equals a 10 and a 2, or 12. And I know from experience what's going to happen with this. The students don't know, but every time we add something else out, we're going to slide it even further and further away. So I'm going to begin by sliding this even further away, because I know that eventually I'm going to have some bigger place values, and I want to have all the place values lined up.
But you wouldn't necessarily do that.
We don't have to, but I don't. I got to lunch. All right, I'm going to go through this quickly.
Yep.
I flip this over. 50 times 3, 5 times 3 is 15, but I need 15 with a 0 on it, which means it's going to be 150. Right? I put these out like this. Okay? And I'll flip this over. And this one would slide down. 700 times 3 would be 21 hundredths. So I'll need to use, and this is the first place where we're going to see negotiation going on. I need 2100, Nicole. She can give me the 2000, but she doesn't have the 100 because she already gave it to me. So this is where the group negotiates. What could she give me instead, since she doesn't have the 2100 I asked her for? Sometimes the negotiation involves people over here, and they might say, well, give them the 40 and the 60, because 40 plus 60 is 100. Fine, I'll put it over here. That's one way. Notice there's no right way to do this. Another way, somebody maybe that's looking over here might say, Joel, give her back your $100 bill, and she'll give you a $200 bill in its place. Right? So there's another